This is a turbine that I made in a previous video. The generator gave only a few volts and I genuinely wasn't happy with that, which is why today I set out to make upgrades to the design of the turbine. Towards the end of that previous video, I pointed out the reason why the blades didn't work well. During the course of this build, I noticed how water moves on the turbine. I noticed that water sprays off the both sides and the top of the scoops, and that might be one of the reasons why the generator didn't perform well. So I got an idea to put some PVC pieces at the edges to stop the water from splashing off. I started by removing or trimming off the edges of the blades by using a drill, and to do that I got this mini saw and its screw chock. Attached the screw chock to the chock of the drill. I think I said chock like 4 times in a row and still made sense. Anyway, I then tightened the screw of the blade and used a plier to hold the underside of the blade and turned the screw to make them tight to avoid the saw slipping and flying off during use. And you need to make sure that the rotation of the saw is in the same direction as the angle that the saw's blades are pointing at. I then went ahead to trim off the edges of the turbine scoops or blades, whichever you want to call it. It was all going fine at first, trimming off the areas that are extended beyond the length of the round PVC base with minimal precision, but it still does its job. But after some time, while working on the scoop, the blades of the saw touches the scoops that are beside the particular scoop that I'm working with and snaps it clean off from the base. Then I decided to remove it by hand, and here it is all cut off, and I used a scissors to trim off the edges instead of using a drill. I then started reattaching the scoops onto the surface of the PVC base in the same orientation as the first video. I think you should watch that first video so you can understand how I placed these scoops even without measurements. After lining up the scoops around the PVC, I removed the old central support because I won't be needing it again for this design. I got a flat PVC and placed the turbine onto it. I got a caliper and used it to mark the edges to be able to have a central point where I will need to place the caliper at to make a circle that will still be within the rough mark that I made earlier, and used a scissors to cut off the edges. I avoided going into the final mark I made with the caliper because I didn't want an uneven mark around the circle. I used the same caliper to make another mark on another PVC, and therefore I got 2 flat pieces. I then made a hole through both PVC pipes and used the screw chock for the mini saw to place the 2 round pieces together, attached the chock to the drill and tightened it. I then got a sanding paper and used it to rub against the PVC pieces while they were spinning with the drill to be able to get an even round surface on both pieces. After that, I placed the pieces down and placed the turbine on it. I tried to keep the turbine in the middle without any measurement. When I got it right to some point, I put some glue around the PVC and on the scoops that are touching the flat PVC to secure them tightly. I repeated this process with the second flat PVC, and this is it, all done. It looks rough because of the mess from the previous video, but aside from that, it looks promising and I think it will do just fine. After passing the shaft through the PVC and glued them together, I got a board that will be used as the base of this experiment. Some PVC pieces that will hold up the turbine and the gears. I then got these bottle caps. I used them in previous videos, and just like those videos, I will place the caps on either sides of the turbine through the shaft before placing the pieces that will hold up the turbine. I then place the turbine onto the spot where it will be mounted and set them down with super glue. These triangular pieces I added to the backs of this piece is to hold them strong and upright to stop them from moving back and forth, which would disrupt the rotation of the turbine. After adding the second one by the other side, all that is left is to get the gears and put them to the shaft. The gears doesn't fit the shaft, so I added a paper strip around the shaft before adding the gears, so it can sit in the center of the shaft. Spinning it, the gear shows no sign of movement other than rotation. This is the generator that I've used for quite some time, made from the rotor of a mixer motor and the magnets from the starter motor of a generator. I placed 3 PVC pipes under the base of the generator to make it have the same height as the turbine so they can mesh correctly. After some shifting and tweaking, changing and shifting the generator to mesh correctly, I applied glue to the PVC pipes to hold the generator at just the right distance from the turbine for them to mesh correctly. Now that the build is done, it is time to test this new turbine to see if it is any better than the first one. Right off the bat, it refused to work until I squeezed the hose a bit to create more pressure. It spins more freely and much better than the last one, making it to look promising. Connecting the multimeter to the generator, we can see that it generates quite some voltage.
Okay, yeah, let's see what this will do. 1, 2, 3, 4, 5, 6, 7, 8, 9. Did I just see 13? I think I just saw 13 volts. Wow. Oh my god, this water is crazy.
Soaking me. The word I was looking for was soaking me. And the way the water moves off the scoops around the turbine is mesmerizing to watch.
Wow. I think this is the highest I've gotten in a while. Wow. You know, the last one I did before I made some adjustments. You know, this particular turbine, the last one before I made some adjustments, it gave me just around 2 volts, or let's just say 3 volts. But this one is giving me up to 13 volts. So, which means that this plate that I added here is really making a difference. It's making a very big difference.
Alright, we can say that these flat pieces I added by the sides of the turbine made a huge difference. And that's it for this experiment. Remember to like and support these little efforts of mine by subscribing. Turn on your notifications to know when the next one drops.
But until then, don't just build, bend the rules while doing so. Make some noise, make a mess, and then make some sense. If it works, don't touch it. Until next time, I'm Emmanuel, and this is Nexella.
Now the honest truth is that we are getting this much because of this gear ratio here. You know, the big one is driving the small one. Maybe next time I'll try to make it a direct drive to know what this can actually produce. on its own without any gearation. But I'm really glad with how this project turned out. Wow, 14 volts, 16 and 17. Wow. This is really doing too much. This is too much. Alright. I've really destroyed the whole compound just because of this. So